Here. In this video, we will be discussing on Langchain retrievers. So just to recap, we have completed data injection pipeline. We discussed about loaders, splitters, embedded and vector store. Now we are in the retriever and generation pipeline. In this video, we will be discussing on the retriever module. A retriever is something that will return the document based on some NLP query. So here we can see that we will have a NLP query and that will be passed to a retriever, and retriever will retrieve the documents. And retriever can be anything. It need not be any permanent storage, but it can be a API also. We can discuss that. And a retriever is implements a runnable interface. So since it is implements a runnable interface, it can be used with the Langchain expression language, and it is also provided with different kinds of methods like invoke method and async invoke method like that. And there are different kinds of retrievers are available. One is search APIs. As I mentioned, it may not always need to be a database. It can be a search API also. We can use the Wikipedia search API, for example, can be a retriever, and we can use a relational database as a retriever, because we can use a text to SQL in which we will be giving the NLP and the retriever will retrieve the data based on the NLP it will convert the NLP to SQL query and it will retrieve the data. And similar to that, we can use the graph database as a retriever, in which we can convert the text into cipher query. Cipher query is something that is understood by the graph database, similar to SQL. And we can also use the lexical search, in which we can use a text matching algorithms like BM24 or TF-IDF. And also we can use the vector store as a retriever. So these are the common type that we are using as a retrievers. Okay, so we can see one by one, and in this video we can explain or we can discuss more about vector store as a retriever. For that, let me open my Visual Studio Code. Okay, so my environment is selected, all things are good. Now first, what we can do, we can create a vector store. Okay, for that we can do our Langchain community. We can import the document loaders. Okay, I can import the text loader here. Then we can import the text splitter, Langchain text splitters, and we can import the character text splitter. Then we can use the Langchain maybe OpenAI, or I can use the Olama embedding. I can import the Olama embeddings, and from Langchain community vector store I can import the FAISS. Okay, so this is we all discussed about all these modules, right? So I think this will be very simple, and I can use a text loader. This can use copy path. Okay, so this is my loader, and I can have a documents. For that we can use the loader.load. So the loading will be done. Then we can use the text splitter. Text splitter will be character text splitter, and chunk size will be 1000, and the chunk overlap will be 10. So I can have a text here, and text splitter dot split. Here we are using the split document, and I can pass the document as documents. Good. Now I can use the embeddings. Here we will be using the Olama embedding, and we will be using the model as Llama 2. So let me check the model name correctly. Sometimes I forgot that here. Okay, this is my model name. Okay, so instead of this Olama embedding, we can use any embeddings. Okay, so I am using this because it is free. Now we can have our vector store. We can create a vector From documents I can pass the text and I can pass the embedding as a embedding. So this will create a vector store. Okay, once the vector store is created, then we can create a retriever. Creating retriever from the vector store is very simple. We just need to have a vector store dot as retriever. So this will actually convert a vector store into a retriever. Okay, now we have got our retriever. Okay, and let me give a query, like I can use a retriever dot invoke. I can do a invoke and I can pass what did the president say about Ketanji Brown Jackson, something like this. Here we have the, let me check the docs. Here we can see the documents. So basically the retriever is using the similarity search, okay, but we can use the maximal marginal relevance retriever also. Okay, for that what we can do, I can just try retriever dot invoke. Here I can give, not here, so when I create a retriever, here I can use the MMR as a parameter. Here I can pass search type as MMR. This will give more complex, this will do the more complex analysis, and it will check, it will try to avoid the duplicate, and it will bring the more accurate result than the cosine similarity. Okay, so it is a retriever MMR, and here I can use the same query here. Can print the docs. Okay, so the result are same. In this case the result are same, but we will able to change the search time as a MMR. Now another way is that we can also apply the threshold also. For that what I can do, when I say retriever dot threshold, okay, here I can say that vector store dot as retriever. Okay, here I can mention the search type. Search type as similarity score, threshold, okay, and search keyword arguments, what I say here, I can mention the score threshold, here I can make 0.5. Now let me execute this again. Okay, retriever, sorry, I just, here there is a mistake, here I have to use this document. Okay, just a second, I made a mistake earlier. So earlier I have used the retriever dot invoke, and here I changed that to vector store, I mean retriever MMR dot invoke. So in this case we have used the MMR, then you can see that there is some difference in the document that is returned from the vector store. Here we can see that tonight, am, and I am, and my, and putting. So when we do the second time using the MMR, it is actually giving the tonight, puttings, we are, inflicting, and unlike $2. So they have made some changes with respect to the document that is returned from the vector store when we use the MMR. Okay, so you guys can check which one is more accurate to our use case. Okay, so here here what we are doing is that we have a retriever threshold, and what we are giving some kind of a threshold, and we are saying that okay, this is the my threshold, and you have to return records which is more than 0.5 threshold. Okay, so here the search type is similarity score with threshold. So let me see how this works. We have the retriever and I can have a docs here. Okay, here we can see there is only one record with respect to with that threshold. That is why we are getting the one record from the result. Okay, so that is all about in this video. So the agenda was to discuss or to introduce about the retrievers, and we discussed about how can we use a vector store as a retriever. Okay, so here we have what we have done. Okay, so this the first step, that is very clear. We created a loader, splitter, and we created a vector store. Once the vector store is created, this is very simple to create the retriever from the vector store. We can just use the as retriever, then we can invoke the query. There are different algorithms that can be supported. Okay, one is the MMR. So when we use the MMR, it is actually little bit more complex than the cosine similarity or similarity search, because it is internally will check the relationship between the document, and it will try to avoid the duplicate records also. Okay, so that is what the retriever MMR will do. Okay, so when I can use the retriever MMR dot invoke, this will return the different kind of a document. Okay, so this will be maybe sometimes will be more accurate with respect to the similarity search, but based on the use cases it may vary. We need to check out the result based on our use cases. Then we have discussed about the retriever threshold. Okay, so here we will able to give some kind of a threshold. So here I am giving a score threshold as 0.5, which means you have to filter all the records that is less than 0.5. Okay, so this will give me a correct or exact result which has a more value. Okay, more threshold than the other records. So this will give more context, more correct context to the LLM models. Okay, so that's it, and please do like and subscribe. Have a nice day. In our coming videos we can discuss about more and more about the vector retrievers, retrievers, because there are different kinds of retrievers are available. Okay, so thank you very much. Please do like and subscribe. Have a nice day. Bye bye.